Good evening. My name is Derek, and what I'm doing here is my second ever Tidy Tuesday data exploration stream. As you can see on the screen, I am a data science instructor at the University of California at Merced. And what I'm hoping to do in this video is to carry out a 1 hour intermediate exploratory data analysis. That is, I'm hoping that videos like this bridge the gap between starting up with the R programming language and carrying out this in practice. So what we have today is a data set from the folks at Tidy Tuesday. This came out on March 17th, 2020. And the data is from a library called Shrewd. And the data is about the TV show The Office. Fortunately, the folks at Tidy Tuesday make it easy for us to practice with the data by having a line or so of code that will allow us to quickly gather the data into our RStudio experience and other information as well about the data set. So to give you an overview about my easy workflow, I'll go to New File, R Markdown. Since we're working with the Office data today, I'll call this file the Office, and we have an R Markdown script here. This layout at the beginning is a tutorial. You could look at this if you want to. I usually go ahead and delete this at the moment. And while I'm here, I try to be in the habit of saving my file. This is an R Markdown document, so be sure to save the file with the extension .rmd for R Markdown. As you can see here, the line of code uses the readr package and its readcsv function to bring in the data, and it'll be saved as a data frame called office ratings. Assuming you have the readr package and an internet connection at the moment, we get the data frame to show up here in RStudio, verify that it shows up in the upper right hand corner. One way to view the data quickly is to click on this data frame name in the upper right hand corner in the environment, so that we could see we have the season number, episode title, a rating in the Internet Movie Database IMDb on a scale from 1 to 10, with 10 being the highest, the number of votes for that episode, and when the episode originally aired. Other ways you could look at the data in RStudio, I like to look at the column names of the data frame to get a sense of what that they are. And also the summary command could help us get a sense of what the data looks like as well. So here we can see that season, episode, total votes, as we expect, are numerical in nature. Air date are a bunch of dates in the year, month, day format. Internet Movie Database rating is also numerical, and the episode titles are what computer science is called strings. More precisely, we could look at the structure of the data frame using the str command. So we can see here R is calling this data, the structure of the data, some sort of special table data frame, or it could be handled as a table data frame, tabular data frame. So, sorry, in the lingo it's called Tibble. And just like what we saw above with the summary command, we see that season, episode, IMDb rating, and total votes are numerical. The episode titles are in a character format, and the air dates are in a date format. Now, this being Tidy Tuesday, we may need some code from other code packages. Fortunately, the folks over at Tidyverse have arranged most of this for us. What showed up before when we loaded the data and looked through some of the summaries were warnings or messages that we might not need at the moment. So my habit is to set message equals false, warning equals false for now in the R Markdown document. For the code blocks, the keyboard shortcut I've been using is Control Enter to run a line of code, or Control Shift Enter to run a block of code. And those keyboard commands are here in the top right when you click the down arrow next to the run button. And also, as a good habit, considering your workflow, you might want to save about every 5 minutes. And just like what I did in the bottom left in the console area, it's a good idea to dive into the data by looking at, say, the column names and the structure. So I'm going to bring those 3 lines of code into this markdown document. So that way when I press knit on the document, this information will show up in the report. So now I think we'll simply play around with a few graphs, try to get a visual sense of what the data looks like. And I think we'll first look at box plots. We're going to take our office ratings, pipe this into a ggplot. And let me bring back the column names. So let's say we have the seasons on the x-axis and the Internet Movie Database rating on the y-axis. To restate what I just did, I'm taking the office ratings data frame. I'm going to plug that in, or in the lingo, we say we pipe that in into the ggplot function. This will ggplot will handle a lot of the data visualization, making the graph. I put season on the x-axis and Internet Movie Database rating on the y-axis. Now, you'll notice at the moment, nothing really appeared other than the axes, and that's because this line of the code in the grammar graphics, this is usually what I call the what. What are we graphing? So what we then do with a ggplot is then supply what we call a layer. And this will tell the computer how we want the data to be presented. So now we start to get a box plot. And at the moment, it's just summarizing all of the IMDb ratings for all of the 188 episodes of The Office. It's not a really inspiring plot by any means. And furthermore, RStudio is being a bit foolproof here by specifically telling me you might have forgotten something along the way. So to get this to work as intended, we're going to group the data by season. And there we go. Now we start to see a story unfold. Recall that from your statistics class, a box plot shows the median for, in this case, the IMDb rating. And this is over the seasons. So the first season started relatively low. The medians increased to peak out around season 4. A little bit of a dip here, 5, 6. Slight climb at season 7. And another decrease at seasons 8 and 9. So if you were wanting to make this a publishable level graph, what you might be asking yourself at this point is, what do you need to add to this in order to really make the data readable or palatable to your audience? So we could, for one thing, affect the colors of the graph. We could fix the x-axis tick marks so that the numbers 1 through 9 appear. And also, we do have some situations where we have some outliers. You see these dots here. And I'm noticing, according to the way R is doing the box plots, 1, 2, 3, 4, 5, 6, 7, 8 outliers. So perhaps we should try to figure out what those are as well in relation to the Office TV show. I think what I'll do is I'll try to make the code available later. So I'm going to separate each of my main thoughts into a separate code chunk so that this is easier to follow for an audience member later on if desired. One point of contention that comes from diving or first exposures to the tidyverse is that we use this pipe operator, the percent greater than percent sign, in between a data frame and ggplot. But inside ggplot itself, we use the plus sign in between lines of code. the lingo is that we're adding layers to our graph. Here in a section I'm calling titles and labels, we're going to add a layer called labs for labels. So I'm going to have a title, let's say the office. Let's put something in the subtitle to tell the audience what we're looking at. In this case, it's going to be the Internet Movie Database ratings. You could go from there and specifically say on a scale from 0 to 10 or whatnot if it's not as obvious on the graph. But just like the folks who originally made the data from, I think I'll assume familiarity with the Internet Movie Database. Another habit I'd like to be in is to cite my sources. And as you can see there, what I did is in the caption, I'm going to source my data that's coming from Tidy Tuesday and the Shroot package. So now to see what that did with the graph, the title appears here in the top left in boldface. The subtitle appears right after it. And the caption appears in the bottom right. While we're here with the labels, we could also label the x-axis. I'm going to change the label to the x-axis to season with a capital S. And at the moment on the screen, you could see the variable name IMDb rating on the left side of the graph for the y-axis. Computer programmers like to have that underscore there to avoid headaches later. But for labels themselves, you could go ahead and put this space back in. And it's a good moment to put in the units as well. So I think what we'll do next is kind of in the sense is if you had a limited time frame, like I'm limiting myself to an hour right now, try to get as much done at the beginning and then fix maybe more minor issues towards the end. And of course, with programming experience, I have an idea of what are easy fixes and what are more difficult fixes. So we'll do some color coding. And admittedly for today, we'll focus on default colors. I'm streaming this on Twitch for my own convenience, and just give me a second while I talk to my chat. The easiest way to add colors to this graph, the box plots, is going to use the fill parameter here in the ggplot line. And after every 2, 3, or 4 commas, I usually like to press enter to clean up my code a bit there. Remember, all I did was add this bit of code here, fill equals season. And we have this color scheme here, which for one line of code is, in my opinion, pretty impressive. However, on the math side of things, even though the season numbers go from 1 through 9, I believe, 1, 2, 3, 4, 5, 6, 7, 8, 9, yes, 1 through 9, they're not necessarily thought of as a continuum at times, and we might want to have these as separate colors. So give me a minute while I think about that for a bit. I think what I want to do with the office ratings, specifically the season, is I'm going to convert this to a factor. So I'm going to take the seasons and at the moment it doesn't really sound like I'm doing anything. I'm literally labeling season 1 with level 1, season 2 with level 2, and so forth. There we go, with the factor command. What this looks like internally is now season is said to have a factored data type rather than a numerical data type. And you'll notice once again I have these levels where I relabel the numbers. More specifically, I know I'm going to get an output of 188 numbers here, actually times 2, so I'm just going to let this go. The seasons are presented in order, and the levels are presented as such as well. And admittedly, it's hard to see what these levels do. But we have this chunk of code that still tries to make a different color per season. Now, trying to be a good programmer, I should comment my code, shouldn't I? The skill is called a data type conversion, and we converted that variable from a numerical to a factor. And now we start to see, with all that prepping, we could get a very colorful picture to start to tell a story. And another issue that we fixed, coincidentally, notice the x-axis tick marks. Now they don't say 2.55 and 7.5. Now they actually do say 129. So that was an added bonus. One thing I usually do here in relatively simple graphs is that if it's pretty obvious what the different, in this case, rectangles are, in this case, they're seasons 1 through 9, we do not really need this legend on the right hand side to tell us what does red symbolize, what does orange symbolize, etc. So we're going to remove the legend as well. The command, I believe, will be part of the what we call the ggplot theme. And I'll confess fully, I do not have these lines of code memorized. Whenever I need to do tasks like this, even tasks that I've done 100 times, I'll just go ahead and do a web search. So on my second monitor, I'm going to pull up Google and quickly reassure myself of how to Google this. So what I Google is ggplot2 remove legend. It's such a common search that is practically one of the first search items that appear in the suggested searches. And in fact, Google will bring this up in their search results rather than having to click on a page. Though, to be fair, it's nice that people have already posted this information online. So the parameter is legend position. What this does is you could put your legend above the graph, below the graph, to the left or to the right of the graph. And then the clever trick to get rid of the legend is to say that the legend's position is none. There is no place we want that legend to be on the graph. So now the legend on the right hand side disappears, and we could focus more on the graph itself. Another thing I usually do is, for people outside of R programmers, I usually remove this gray background, especially if we really don't need the granularity of the y-axis. That is to say, perhaps in the long run, we don't really care where y equals 7 is, where y equals 8 is, and where y equals 9 is. I might go ahead and remove the gray background. If I was doing a quick work of this, I would use the theme minimal command to get rid of the gray background. But this being a more intermediate coding session, let me go ahead and bring in a line of code that's a lot more direct. I should credit the websites I'm using when I do this. So the element, we're going to put this inside the theme command, and we have a parameter called plot background. you can see that this is a gray rectangle, and internally it's called a rectangle element. Just for fun, let's just run this line of code, see what it does. And that will actually affect this part of the rectangle. And that's not what quite what I wanted. So we could get rid of that part with element blank. Moving right along, rolling with the punches. We'll try a panel background now. Try to wipe that out with element blank. And there we see that's another way we could get rid of the gray background. So it's this specific line of code. That allows us to do so. We're a little over halfway through the video, and what I think I want to do next is see if there's a way we could explore these 8 outliers if possible. This is going to be a tough battle, and I admit I might not be able to finish this in 20 minutes. So this time around, what I want to do is we're going to once again pipe office ratings into a ggplot. And let me see if a scatter plot works for now. So we have a scatter plot there. That is to say, we have a more discrete version, or a more granular version of the box plots we made in the previous graph. And what I'm hoping for is to take some of those dots and label them. Now, let me show you this thought process, perhaps one step at a time. So the line of code will be geonText, and I believe this will run into an error at the moment, because when I tell R to start labeling the dots, R goes, well, what do you want to label it with? Go back up to the aesthetics. And I did that step pretty quickly. What I did was, back down here in the console, I refreshed my memory of what the column names were. And actually, I want title here. The episode title. So this line of code is pretty efficient about bringing in the episode titles. Of course, the issue is that across 188 episodes, the lines of code tend to the episode titles tend to run right into each other and creates a very messy picture. So somehow we are going to select the titles, hopefully for these 8 outliers, but from these labels here. Believe it or not, we're actually going to have to use some mathematics. So let's call this stage of the process finding outliers. I'm going to take the office ratings, and what I want to do at first is just get a sense of where the medians are, the median for each season. And let's call this data frame DF for data frame. The reason I did that is because while there are commands such as summary or structure, if I want to look at just the data itself, I find it easier to click on the data frame here in the top right in the environment. So you can see what I did. What I did was the mutate command here was add another column to our data called median, and that's on the right hand side of this data frame. And you'll notice that it's saying that the median rating was 8.2. You'll also notice that it says that the median rating was 8.2 all the way down, because I never told the software just yet that I wanted this done season by season. So we're going to do that season by season with the group by command. Thanks to Tidyverse, this is very straightforward. At least I assure you, much more straightforward than the way we did this 5 years ago. And then we put group by season. Now, as I hinted at before, for the actions that we're doing here in the Tidyverse, in between the steps, we use the pipe command, %. Later, when we get back to the ggplot, we'll use the addition sign to add the layers. So now, with that line of code in there, here season 1 had a median of 8. Season 2 had a median of 8.4. Season 3 had a median 8.6. In fact, let me show that to you down here. Let me take that data frame, pipe it into a summarize command. Let me see if that works. So once again, we have our story that we're trying to tell here, that on a scale from 0 to 10, season 1 had a median of 8. Season 2 had a median 8.4. We're, according to the medians, have a peak at seasons 3 and 4. Everything starts to dip down a bit for a TV show as it naturally ages. Now, we need to get a sense of where the outliers are. that the box of a box plot makes the 70th percentile minus the 25th percentile. So we're gonna take our data frame. We're gonna make and calculate these values again. I think the group by was already there. We'll check that in a bit. And at the moment, I'll fully admit, I don't remember what the command was for percentiles. Oh, of course, it's the quantile function. So we're going to take the quantile of the IMDb rating, and for the 25th percentile, we'll put in 0.25. And while we're here, the mutate command can actually make multiple columns. So we're going to make the 75th percentile with a little clever edit of the code. And it would help if I save the data. When you want to save the data, make sure you still have your arrow. So now, the 25th percentile, that is the bottom of the rectangle of the box plot, and the 75th percentile, that is the top of the rectangle of the box plot. Now these are calculated. Some bit of laziness I took advantage of. Since I grouped by season up here, I never did a step called ungroup, and the percentiles, the 25th and 75th percentiles, were still done by group. So now the whiskers of the box plots, the lines that stretch above and below the box plots, that is these lines here, above and below the colored rectangles, the distances are what statisticians call 150% times the IQR. We take the distance from the top of the rectangle to the bottom of the rectangle, the 75th minus 25th percentile. We multiply that by 1.5, and then we find out how far from the median that will be. So I think what I could do now is we're going to find our IQR first. By definition, the 75th percentile minus the 25th percentile. And with the lazy group by season I did earlier, this IQR is found for each of the 9 box plots for each season of The Office. Sorry, have a bit of a cold. I quickly calculated the location of the top and bottom whisker. Let me quickly verify that I have those locations here. Now, I want to take this calculation and then carry it out with our data from the office, but it's probably a good idea to start a new code chunk every once in a while. So we'll say we're finding the names of those outliers. I want to take the code that we did for the scatter plot, that is this one, and see if we could focus on the dots and the episode titles that will eventually be deemed an outlier. So between the data frame name and the ggplot, let's see if we could make ourselves a Boolean variable. We're going to take the Internet Movie Database rating, and if it's greater than the top whisker, or if the Internet Movie Database rating is less than the bottom whisker, we're going to return the episode title. And if not, we're going to return just a blank space. So the way that if else statement works is running through this logic again. If the Internet Movie Database rating is above the top whisker or below the bottom whisker of the box plot, we'll return the episode title as intended. Otherwise, if the episode was kind of a normal episode inside the box plot, we're going to return virtually nothing. So now I kept the points here, the black dots, just for our example, but we actually do not need them right now. So I'm going to get rid of g on point. And instead of all the episode titles, I'm going to see if this outlier title works for our label. Cross your fingers. And that did not quite work out because I called the data frame df, didn't I? Let me check my parentheses here. See, there we go. We're starting to focus on the episodes that were either very popular or the ones that were not so popular. Now let's try to add those labels back onto the original graph. So where was my good graph? Back here. From the office ratings, we grouped by season. We found a median. Then we found the 25th and 75th percentile. Then we did the calculations with the interquartile range, the IQR. We have our graph here. Let me just run this code to see if I run into an error. Looking good so far. We also then, with the top and bottom whisker, so mind where the line of code will go. We created a column called outlier title. Then finally, back into ggplot, we need to label with the outlier title, put on a geom label layer. Now, admittedly, I did not complete my goal. I didn't focus on just those 8 dots originally, but let's see how this plays out. So now we have maybe a little too much going on with the box plot itself, but we accomplished most of our goals today. So let's see if we could fix that a little bit here. Perhaps if I focus on the labels inside the geom label line. No, did not quite do it. Running up on time, but perhaps I could have figured this out real quick. I know what I did. I'm still labeling all 188 episodes. It's just that some labels are empty and some are not. So what I'm going to try to do is for the back up here in DF. I'm actually going to filter back up here. So now the data frame only shows those. The data frame I labeled DF only shows those highly popular or unpopular episodes. Got a little carried away back here. Don't need this anymore. The data frame, the episode title is still called title, it's a lowercase t. Isn't programming fun? And look at that. There we go. Alright, so I'll have this video uploaded to YouTube and I'll have the source code available on RPubs soon. But thank you for trying out and giving me a chance to present some Tidy Tuesday ideas to you. And I guess my sign off will simply be see you next Tuesday. Bye.